Hello, this is Grant Park from the High Throughput Sequencing Data Search Group, and I'm going to demo the product that we made. So, quickly I guess I'll explain what we were tasked to do. Our task was to scrape the SRR code links from GEO that are used with FastQDump to download raw genome data. So specifically what we're looking for were articles pertaining to ribo 0, rRNA depleted, ribo minus, or ribosec that specifically were under the study type of high throughput sequencing as listed below. So these were what by default we were filtering for. But as we were making it, we realized that this would work for any search that you wanted to do in GEO. So we have it to where if you don't give, it's a command line program, so if you don't give it an argument, it will use this default URL that we created. But if you want to just search something else, you give it that argument and then it will search the URL you give it. These URLs can be created here on GEO with their advanced search builder. And you can see here, this is the URL that we created to search for the articles that we wanted. And actually for the demo today, I'm going to be using a custom URL that we made because this is the default one. So the default one gives you 1,073 articles, and on average it takes around 7 hours and 30 minutes, which we obviously don't have time to do today. So I'm going to be using this one, which has 8 items. So let's take a look at the program itself. Like I said, it's command line. So on Windows, you can run it through PowerShell, but it also works on Linux and Mac. This is the folder where the program is stored. GEO Scraper, that is the main program. So that's the program that you're going to execute in PowerShell that will run everything, and it controls all the main execution and flow of things. Scraperfunctions.py, this contains all of the heavy logic code that was used in our scraping just to clean up GEO Scraper. And then scraperobjects.py was used to store all of the objects that we used to help make the program a little bit more simpler to read what was being returned, because having a 2D array for everything can get kind of complicated after a while. So let's get right into it. I already have this command ready. So this is the search URL that I showed you earlier for the shorter one, and so I will run this. Now what you'll see is 2 files, or actually 1 file so far get created. Go back to here. That ribo links, and the browsers that are coming up was because of Selenium. It's a web driver that lets us automate controls of a web page. And so the 2 files that are created upon execution, ribo links, this is where all the scraped data is stored. And then text or keys.txt is where the article ID is stored, and that makes it to where if you run this again, it will not scrape articles that you've already scraped previously. It will only do new ones. So you can run this over and over again, and you're not going to have to do the 7-hour wait every single time. That's just for the first time. Now you can see here, it gives you the article title, and then it gives you, these are the sample titles. And I'll go through the browser and kind of show you what we are scraping and why we're scraping it. And so the reason we have these sample titles being printed out was just so that way the user knew that it kind of worked like a loading progress bar. It let the user know that it's still scraping, there's not an error, because for especially long for samples, or for articles that have a lot of samples in the thousands, it can be sitting there for 30 minutes to an hour. So it can be concerning if it's just the beeping cursor. So while this is going, I'm going to show you what we are scraping, just to give you an idea of how we're doing it. So we get to this base page and we scrape all of the article titles and then the hyperlink that this article title goes to. We copy the GSE right here, and we use that as the parent folder where all of the SRR files will actually be stored to help group them together, and we'll see this in a bit whenever I show the Excel that's created. This ID is the one that's stored in keys.txt, so that way we don't repeat the scraping of the same article. And then if this is available, we get the hyperlink to this SRA run selector. This is a faster way that you can scrape the data, but it is not always available. So first I'll show you the what we call the slow route to get the data. Now whether you do the SRA run selector or the slow route, you're always going to have to go to this article page to scrape the status. You're going to scrape the organism or organisms. You're going to get all the contributors. You're going to get the organization name. And then we're going to get the platforms. Now, here's where the difference occurs. So if you're going on the slow route, you're going to scrape all of these hyperlinks, and then you're going to pair them with this sample title. And so these will be paired together in an object. So it's an array of objects that store these two together. And so the next step, and this is again for the slow route, you'd go to where this hyperlink takes you. And the only thing we would get here is we would get this hyperlink right here, and we'd go to it. This is what we call the experiment page. And so this is where you'll actually get your SRR code. This is where, and we also scrape, we scrape the size of the sample. And that's all we do for the slow route. Now we're going to see this page again with the SRA run selector, but we will be scraping some one more thing if we're doing it through the SRA route, and I'll explain when we get there. So let's go back. So if this SRA run selector does exist for an article, we will go to where that hyperlink takes us, and we will scrape all of these hyperlinks to the experiment page that I showed you earlier. Now you might be wondering, why don't we just scrape the SRR code here? We could, but the problem with the SRA run selector table is that it isn't consistent with the data it gives us or how the data is labeled up top. So here, this is a table that has all the information that we would want. It has the size of the file, it has the sample title, it has our SRR code. The problem is, if you go through all of these tables, which I don't recommend you do, you'll see that sometimes this information isn't available, sometimes they change the header. It made it to where we couldn't reliably scrape the data we wanted, but we always knew that we were going to get this SRX link. So we scrape this and we go to it, just like in the slower route. And then we take the same data as the slower route, we take the SRR code, and we take the size. But we also take this sample right here, which is the sample title. And this is because the experiment page is consistently structured like this. We can trust that this is how it's going to be set up, so we can scrape the data reliably. Now you notice that that's only one GET request less, but it's one less GET request for every sample, which adds up really fast, especially for articles that have, thousands of samples. That adds up a lot. So I think that's enough of explaining what we're scraping and why. So you can see here that it finished, and it gives you the time it took to execute. And you can see that it made the Ribo links CSV, and it created the keys. I'm going to show I'm not going to actually show the YBL links that this one created. I'll show a completed run of the default URL. I just wanted to show it running in terminal, so I'll bring this Excel file in. So this CSV can be opened in Excel. And so this is the information that is scraped from a full run of the default route. So you can see the information that I was pointing out to you. We filter the SRR code. So we format it so that way the researcher or user can just copy and paste this into terminal and just run it. They don't have to format it or anything. And so it uses the GSE of the sample as the parent folder, and then it will create a subfolder in that folder to actually store this SRR data. And so you can see those of the same article will be stored in the same parent folder to help organize things. Here's that SRR title I was talking about. So there's the size that we were scraping, the organism, and some things they just aren't available, and so we specify those with in-A, platforms, organization name, contributors. Since this is a CSV, we can't separate things with commas, so we use a pipe to signify that those are separate strings, status, and then the article text. And so yeah, sometimes you can get some weird things because we're replacing commas with the pipes, but it gets the idea across of that this was the article name. So this was a demo of the high throughput sequencing search. Thank you for watching.